I'd like to thank the organizers for the kind invitation. It's a pleasure to be here with you all. So I also want to thank the center that I represent, the Kotak IISc AIML Center. So this kind of work is exactly in our mandate. So I'm hoping that if you find some of these ideas useful and interesting, we would love to contribute to its implementation across the country, and this would be a wonderful state to start that process in. So I'm going to structure my talk in two parts, and I'll also cheat and tell you ahead of time what I would like to convince you of, so that you have something to fight against if you disagree with me, okay? So I'll reveal my objectives, right? So I'm going to talk a little bit about how I see generative AI impacting teaching learning processes, and as a consequence, do we see changes being necessary to the way we teach, the way we assess? I believe in some domains the answer is a definitive yes. In some domains the answer is maybe qualified yes. And I'll focus on those domains where I'm confident. And I will also suggest a good starting point, okay? Something that we call refute questions. I'll explain these in detail so that it's something concrete for you to take away. And again, something to sort of maybe push back against if you disagree. And maybe in some domains you will disagree. So this is all based on stuff that we've been doing at IISc, and although that is in the context of introductory programming, I believe this is very generalizable. In fact, colleagues here at IIST, in fact, where I've been visiting, we are working on trying to generalize this to other domains. So far, we're thinking of engineering domains because those are the people I hang out with, but there are many other domains, hopefully, where this might work. I don't know if it can be extended, for example, to musical education, for example, but you let us know. I'll also briefly talk about how to implement this at scale, because that's part of the title of my talk, and I'll talk about this collaboration that we're doing with NPTEL. I won't take up too much detail there because you're going to have a talk by JK straight after this on that. But I will talk about the model that we're trying, and this is the kind of model that currently we're doing purely online, but I think it's probably better to do it at least in a hybrid mode. And this is what I would end with. Okay, so let's focus on this part, right? So I'll focus on domains where our emphasis as educators is on getting students good at creating complex artifacts. And I think this covers a lot of domains. Certainly it covers my domain. I'm a computer scientist. We get students to create these complex artifacts that we call code, right? And mathematicians do this, journalism school does this, MBA students do this, research scholars do this, right? Now all this content that we want students to get good at, we spend an awful lot of time getting students equipped to create good quality content. And now that it's out there, of course, along comes this AI crowd and says, thank you for all that lovely, delicious content, because we're just going to ingest it and use it to train our AI models, right? So if we believe that the world cares about all these complex digital artifacts and is willing to pay, say, a computer scientist a significant salary to be able to produce these complex artifacts, wouldn't it be nice if we could generate it, for them? And thank you for all the training data. This process takes an enormous amount of energy, and this is just one of the many ethical challenges around it. It does contribute substantially to the level of CO2. But the upshot is, once this model is trained, this is a one-time payment. Once this model is trained, you can have someone who is a relative novice in that domain, relative novice in that domain, and we spoke about prompting. I do believe that it is in the interest of the people who create these models to make sure that you don't need to be super well trained to prompt them carefully, right? So while the previous speaker did talk about prompt engineering being a thing, I feel that's perhaps true now, maybe true for a short while, but I think gradually it's going to become less and less true if all the people who are designing these things are very clever. And once you have a set of ideas that do work, it's just a matter of integrating them as a front end to these models. So here's my relative novice. I hope you like my cartoons. I can't draw by hand, but I use generative AI to suggest what to put in there, and that was the suggestion. So thank you. So we can have this person be adept, so apparently adept at many different fields, right? So they will submit their prompt, and the generative AI will churn out some more carbon dioxide in the air and produce this content. Right now, I'm simplifying because the previous speaker explained this process in much more detail. But the inference part, as you have seen, if you use ChatGPT, you've seen it goes, little token by token, is producing the next token. So this idea of next token generation, I'm going to quote from people who know much more than me about these, and I'm going to offer you two very different views about the capacity, the capability of this next token generation, because we did have some discussion pre-lunch about how good this is relative to human capacity. Okay? So I'm going to quote for two sets of people. One is Noam Chomsky and his colleagues who had this article in the New York Times a few months ago talking about how very different generative AI is to the human mind, which we all knew. I mean, the scale at which it operates, the massive amount of data it can ingest, the size of these models which allow it to, for example, memorize a substantial amount of information. So these are very different. And this article argues that in some sense this is a very different form of learning. And the previous speaker did use this term, this sort of idea of stochastic parroting, right? And this is a thing for sure. There is a second perspective, and again, I'm quoting from someone who should know. So this is Ilya Sutskever, who is the chief scientist at OpenAI. And I'm happy to share the slides later. The link in this slide will take you to that point in a 40-minute YouTube interview that he has given, where the interviewer has just asked him the following question. Say, okay, all this large language models, all this stuff is very good. What do you see as the next technological advance that will surpass human capacity, right? Will be more than human beings. And he said, wait, not so fast. I'm not so sure that this fairly simple idea of next token generation isn't already really good. And he said that I challenge this claim that next token prediction cannot surpass human performance. And he's saying this thing that we're sort of belittling, this sort of stochastic parroting, this stochastic understanding, if you are able to predict the next token well, then he's arguing that that itself can only happen if you've understood something. So there is at least at the statistical level understanding which may at least be very practical. Now, as I said, there is a contrasting view to this. Where exactly this is, I am not philosopher enough to tell you, but I am at least practical enough to tell you that where it matters in my domain, can my students leverage this technology to answer all my homework problems? You're damn right. Right? And it's not just that, it's not just in my classroom context, it is in a professional context. And again, I don't want to read too much into this because this is a GitHub blog, and GitHub has every incentive to overinflate the claims about their technology. But they're claiming that the amount of software that is being created by professionals for professional purposes by generative AI is growing. Now, you don't have to believe the numbers, but you can see the trend. Okay? So this is at least understanding well enough to make an economic impact. Okay? And as I said, it doesn't even need to get deeper than that for us as an educational community to at least think about how we react to it. Okay? Okay, so we could ban it. There's no question we could ban it, right? And we could say, thou shalt not use it, and if you do, we have plagiarism detection tools, right? And all of us at institutions, academic institutions, will be inundated by vendors who will say, we have the tools to detect this. And I just want to mention that today, I don't think we're there yet, right? So OpenAI themselves released a classifier, and it came with lots of limitations. These are not even all the limitations. There are more limitations than this. And in my context, since I'm interested in whether students, can I use this to make sure that my students haven't cheated on their homework assignments, I see this and it says, oh, you can't use it for code. And I say, well, if you can't use it for code, then it's not really useful for me, right? But it's not only useful for me, they themselves have acknowledged that it's actually not useful for others because they've withdrawn the tool. So they released it in January and said, this is a classifier that can be used to check, for example, if essays and other written work has been plagiarized. But then they withdrew it in June because they said it's too likely to falsely accuse students of plagiarism. So my student has done the work themselves. I use this tool. It says there's a high chance of plagiarism. I accuse that student on the basis of this tool. Now my student knows the truth. They've really done their work themselves. I've just destroyed any shred of trust between my student and me by using these tools. So there are a few institutions who have explicitly put out policy saying we do not recommend our faculty use this. We're having this debate at IISc at our institution right now about what our policy should be. So hopefully we will also emerge some advice and some guidelines. But I think this is an important debate for all of us to have, and I think I just wanted to share with you that at least for now, even the designers of some of these tools, OpenAI themselves, do not believe in their ability to create plagiarism detection tools for generative AI. Okay? So I think that's worth keeping in mind. And then there's the other implication of banning it, right? I just said people in the real world use it. Right? Now, I don't think we as educators need to be fully dictated by what industry wants, but I don't think we can be ignorant about that either. So I think it's worth looking at. So just thought experiment. Who is industry going to hire? The two options in front of them. Option one is someone who is traditionally educated, and she's capable of creating these complex artifacts that industry wants, right, independent of AI. She doesn't need AI, she knows it. She knows her fundamentals well enough. There's real challenges that her employers wish to be able to tackle, and she is equipped to create the necessary complex artifacts, whether it's code, whether it's a business plan, whatever the domain is, right? She is equipped to do that, right? Of course, she's a human, and all humans do make mistakes. So we recognize that, right? But there's option two, our friend from before. Okay, but they come with a little AI, right? Maybe the industry is saying we're going to hire option two potentially, probably pay them much less because we'll also buy the AI subscription, okay? And the AI will also make mistakes because remember, its understanding is perhaps only at the statistical sense. Perhaps it isn't really deep. But let's also remember that that AI box is not static. We also just heard about how quickly that technology is improving. And you pay your $10 a month or whatever it is, you pay your subscription service, and you get the latest and greatest technology for that price. And there are some very smart people working to make that better. So those are the two options. You have the paycheck. Who are you going to take? Option one, Cliff is going to take option one and a handful of others. Option two, okay, a few more. But there's a lot of abstaining. They're all waiting for option three, right? You haven't seen my slides yet, have you? Because there is an option three. There is an option three. Did you see the change? This took me 5 minutes to get this expression change to that. I hope you like it. Okay? Because that's what option 3 is. Option 3 is same as option 2, but this was our student who learned something very important, which is that they know that generative AI sometimes makes mistakes, and so they have learned how to critique. I think, Cliff, you also mentioned this idea of critical thinking. The idea that we want our students, even if their ability to create has been superseded, at least in an economic sense, by some of these tools, can they at least critique how good it is? Okay? And I want to make sure that we all agree that these are not necessarily the same things. And the way we approach pedagogy and assessment, if our target is critique, could be very different to the way we approach it if our target was create. Generative AI, we said, if you want to be able to create these complex artifacts, no other game in town, human beings have to create it. Human beings have to understand the task and create these complex artifacts. Right? In at least some domains, that does not appear to be true anymore. So the approach that I'm doing in my course and the approach that I'm suggesting that some of you adopt if you believe this is true in your domain is to find room for more critique. And there's only a finite amount of room. We have a fixed size semester. We all struggle to say all the interesting things we want, to try and convey, make room for something beyond just simple lecturing, right? And we struggle with it. And so something has to give. If we want to make room explicitly for critique, then perhaps we have to forego, and at least the trade-off that we have made is we've actually tried to reduce the amount of create. And I'm talking about a programming class. So we're doing less of them writing code and much more of them critiquing code. So we did a workshop on this idea of refute questions, which is what I want to talk a little bit about, right? So I'll tell you what a refute question is. It's very simple, okay? You take a traditional create question. You want your students to create something, okay? Except you don't ask them to create it, you give them a solution, but it's a wrong solution. It's an incorrect solution. Perhaps an AI-generated solution, but perhaps not, and I'll come to why not, okay? And students have to explain, using their understanding of that domain, why that solution is incorrect. This requires them to exercise two skills. Firstly, they have to understand the task that you're asking them. That could involve understanding certain domain-specific words and understanding how important or unimportant they are, and as well as the solution. So if the solution is a piece of code, my student has to be able to read that code and say, oh, relative to the task, this is incorrect, and here's why. It does not require them to write the code. They have to critique the code. And it turns out that this is very easy to align with the present curriculum. Today, you're teaching these concepts. So where you would traditionally say, okay, now let's have some problems where we practice this skill, generating these kinds of programs or creating these kinds of circuits or writing these kinds of mathematical proofs or whatever it is. You can replace those create questions with critique questions. And there you can embed things like common misunderstandings or misconceptions based on your experience as an instructor. So I'll give you one example, which I hope will convince all of us that this is doable. So I've deliberately not picked an example from my domain. We can recognize this. Some of us have terrifying memories of class 9th mathematics word problems, linear equations, but we're all okay with it, right? If somebody forced us, saying you're not going to get any tea break unless you solve this problem, how many of us could solve this problem? Only. The tea is good, no? Coffee? Really? Come on. Your kids could solve it, right? Or they have to solve it. Okay, you can get your kid to solve it, right? All right. So this is the traditional writing, creating, right? We want our students to get good at solving these problems, and we're going to time them, and we're going to mark them to see how many of them they can do, whether that's the right thing or not to do, but that's what we do, okay? All right, here is an incorrect solution to the same problem. Where is the mistake? Now we're going to see who's awake. So you got 8 steps. Who would like to call out on which step is the mistake? Good, you're critiquing. That's what critique is. That's the skill. Not solve it, but critique it. That's an important skill. This solution could have been AI generated. It's not, I generated it, right? But it could have been. Where's the mistake? I'm telling you it's wrong. Sorry? Which step number? 8? 8 is wrong. Their ages are not 4 and 7. So I actually do math school teacher training at our sister campus in IISc Chalakere, as was mentioned in the introduction. Huh? Okay, who said that? Kalpana is younger, therefore which step is wrong? First step is wrong. Third step. Third step is wrong. We've deliberately put the mistake, we could have put the mistake in this region or this region or this region. It would be kind of boring to put it in the calculation region. It's actually much more useful to put it in the code, in the modeling region, right? Because who cares about calculation? We can get computers to calculate. Where do humans need to be involved? They need to parse the complexity of the world and put it in the form of something that can be taken forward by computation if necessary, okay? So it's much more interesting to put the problem, to put the mistake in the mathematical modeling part of it, right? Do you see the problem, right? Do we see why step 3 is wrong? It should be y minus x. And after that, the rest is fine, right? After that, everything is fine. There's no other errors. There could have been, but there are no other errors. But that's the code critique question, the critique question, the refute question. So our student would have to identify the mistake there and explain why. Explain why in that domain that is incorrect. Okay? So it links to something in the task. It said her elder sister. You have to read the task that carefully to realize that that word elder has implications downstream for the artifact that you're producing, which is a proof. Okay? I hope everyone got the point, right? Yeah? Interesting side note. So as I said, I do maths teacher training at IISc Chalakere. And we traditionally do a lot of these, where they practice doing problems, right? So a lot of school teachers themselves do need the practice just to get their own fundamentals clear. But I found that, this was not really very useful to them beyond a point, right? So I said, all right, let's try and give some of these refute questions to them. And I started giving them, and the teachers refused to engage with them. And I asked a colleague of mine who has done much more school teacher training than I have. And I said, why do you think they're not engaging with this? She said, try one thing next time you're there. You're showing them PowerPoint slides with neat fonts. They're used to seeing that in textbooks, and they're used to trusting textbooks. Just give the same problem, write it out by hand. Write it on a piece of notepad that school kids use. Write it in pencil or pen or scraggly handwriting, and just see what happens. And it was amazing, the transformation. The next time I tried that, immediately, teachers were looking at it. Earlier on, they were just sitting back as if, like, how can that be wrong, right? And it got me thinking that if there's a set of people who are refusing to critique something simply because it looks right, then we're really in trouble. Because the one thing generative AI can do with its statistical knowledge of domains is give you plausible solutions in that domain. It knows, even if it has that sort of aphasia, it has understanding of the domain well enough to be able to give you something that kind of makes sense in that domain. So we cannot afford to be fooled by looks, by surface level features. You cannot afford to look at this and say, oh, it's got an X and a Y and it looks like it's doing the right kinds of pluses and minuses. It must be correct. And it's called Kalpana in it and it's got elder and age. It's got all the right bits. It must be correct. How can it know so much and still be wrong? Well, it can. And that's the skill that I think we need to develop. At least today. Today, this generative AI technology has this Achilles heel. It is weak in this sense. And this is an important area that we can stress on. Okay, so that was part one. Part two. Okay. So I'll give you a timeline of part of last year, which was highly exciting. So back in May, life was good. We were planning, May of 2022, we were planning to do our traditional intro to programming course, our CS1 course. We weren't planning to change very much. And then the bombshell dropped in June, which was this GitHub Copilot, which was free for students. Nothing is free. Why do these generative AI creators make tools free for students? Why are students so deserving of free stuff? Yeah? They need the data, right? And students work on simpler problems. So when you're scaling up, it's good to train on simpler stuff. That's one reason. There's another reason. Sorry? They want to popularize, and that's a nice way of saying it. They want their captive audience, right? If they can hook you on this stuff, then by the time, I mean, come on. We're all grown up. We know there are no angels here. They're not simply doing philanthropy. They have a business model to run, right? Okay, so it's free in that sense for students. So that got us worried, right? And we really didn't know what to do. I have a colleague who I know only incidentally at that time, and then he sent me an email. So if you're ever interested in other forms of interesting educational research, go look up Paul Denny. He's in terms of generative AI and especially with regards to its implications in education, he's written an awful amount of papers and he's very, very prolific. Anyway, he was one of the authors of this paper that had come out earlier in 2022 about robots are coming, right? And I had read this paper and he said, hey, should we do this other work he had proposed? So we got working on this, which was extremely relevant while prepping for our semester. So what we did is we took a repository of sort of standard questions that we wanted students to be able to solve, right? And we did this experiment. What would happen if our students took the type of problems that we were going to ask them the next semester for their homeworks, for their labs? What would happen if they just took those and copy-pasted into Copilot? Okay? This tool that was now free for them. Well, we found that it was able to solve 50% of the problems. And by solve, I mean 50% perfect solutions. The other 50% imperfect, but still, if it was a human, we would have said, oh, good job, well done, you're almost there. We would be tempted to give highly encouraging feedback to that student because they would have shown quite a bit of progress. So we said, what else could they do? If they got this score back and they still had an opportunity to submit again, what would they do in terms of trying to improve their score, right? They could, we thought, they could try and improve the code. But we realized there's something else they could do. they could try and improve the question. Make it a little bit more clear what needs to be done. Need to spell out in terms of the steps, the algorithmic steps of what needs to be done. Some of these problems require them to do several things. And if you just gave that complex prompt to the generative AI, it would kind of mess it up. So we said, what would happen if the student actually did this, which, by the way, we would love them to be able to do. Traditionally, we always knew this was very important to do, to teach students to think algorithmically. We rarely found time to do it as much as we would like, because we were spending so much time getting them to write the syntax. They had no opportunity to check if they were able to think logically, think algorithmically, if the code they were producing was incorrect. Because they would never be able to close the feedback loop. They would never be able to execute that code and run it and see if they were right. So this was always important, and we couldn't really do it. And we said, this would be great. And if students engaged in algorithmic thinking, we found that this score would jump up to 80%. So we realized this is, it's a double-edged sword. Yes, we can't do our traditional problems, but we can now focus on things as educators which we always felt were extremely important. So it's actually an opportunity, right? And that's the paper that we wrote. Okay, so fast forward to August, we started writing angry emails. That color is supposed to indicate anger. Very angry emails to GitHub saying, hey, you've made this tool available for students. How about us? We're educators, right? It would be useful for us to understand how to use these tools, to see if the implications they have for education, to see if we need to change some things. We already had by that stage some evidence that we wanted to. Anyway, so we sent, lots of other people I'm sure sent. Finally, we were rather surprised that in September, GitHub announced that this tool is free for teachers everywhere, right? Yeah.
Because of their great generosity.
Well, I don't know exactly. And, frankly, at least one of the email responses I got is, oh, we didn't think about that. And I said, how can you not think about that? GitHub sponsors many computer science education conferences. We go to their conferences, we talk to them. How can you not know about us and not think about it? Well, I mean, they're also siloed. There's probably a business unit and an education unit. I don't know. Anyway, I don't know what it is, but again, I agree. And that's why I put free again in scare quotes there. So at least we have an opportunity to understand the tools that our students have in their hands. Anyway, we decided, our classes started late in October. We told them on day one this exists. November, ChatGPT came out. We told them that exists. Our approach is we don't want to hide it because I don't know what the implications are. By the time my students, I'm talking about first-year students, by the time they graduate, I have no idea how far this is going to permeate into the world of work. I don't want to take the risk that that my students are unprepared for it. So I want them to at least be prepared for it. That's the approach we've taken. And we've used it. And this is one example from our exam, our final exam. I wanted the students to end the course with that feeling that, okay, these things are powerful, but they're not infallible. So this is actually a traditional question. I'm not expecting you to understand the question. I just want you to understand that at the surface, this is exactly the type of question we would have asked, we were planning to ask on their final exam. Back in May, when we were envisaging this course, we were saying, oh, we would ask one of these because we've always asked one of these. These are the types of questions we want our students to get. They have to understand all this funny notation, make sense of it, and understand what it's supposed to do. Who cares what it means? But we changed the question. We changed the question to say, we asked ChatGPT the following. And I put the date over there because I had a feeling that if I ran the experiment a few months later, the answer would change. So I put down on the exam, we asked ChatGPT the following question. It produced the following answer. The question was, where's the mistake? Same as the Kalpana question. Just not with linear algebra, but with this asymptotic analysis. Right? Same idea. And once again, anyone who has seen these kinds of proofs, you will instantly recognize that that is exactly the right way to start it. That's exactly the right way to end it. And somewhere there's a mistake, this time in the boring calculation stuff. Once again, amazing that these tools can understand the domain so well and write so much sense and mess up something so basic. But that's how they work. That's their Achilles heel, as I said. Okay. So that's, as I said, we've been trying to do that. As far as the teacher training is concerned, which is the most important part, which I want to spend some time on, we have been collaborating with NPTEL, and I'm sorry I won't be able to attend my good friend and research colleague JK's talk straight after this, because I am actually going to teach in that same program. 4 to 7 p.m. I have an online session with them, right? So we've been slowly scaling up. Our model is we ask faculty to pay, and we do have some sponsorship, right, for some scholarships through a sponsor. I would like to thank Bytes in Karnataka. But I think this is something that we can find other models for, right? So the idea is, as I said, these numbers for an online program, I would be very happy if we were at 3x these numbers, because I think we can make it meaningfully work for people. And this is just the number of people who are registered. As we know, actual engagement is much smaller. Okay? But just to give you a peek, these are all computer science faculty, so we do refute questions. And this is now, for example, a piece of code that we would typically want a student to be able to write. Instead of having them write it, we'll say refute it, right? Now, I want to clarify that this piece of code was not AI generated. The problem of finding the median of 3 numbers is so standard that any generative AI should be able to produce the right answer, okay? But we want to ramp up the ability of students to critique. Today, what's happened is these things are so good that when they make a mistake, they are very subtle. And so if we as educators feel it's important for students to get good at critique, we have to start them with simpler stuff. Even stuff that AI won't make a mistake on, because the intention is to get them that good at the end. Right? So we've actually got this, and I'm not going to bore you with the details, but we provide them with lots of details. This is for the faculty training. We provide them with flow charts in this case about how to provide formative feedback, how to do summative assessments, and so on. All right? So there's a lot of this stuff. I just want to flash the slide in front of you to give you a sense of the level of detail that the FDP gets into. We want faculty to get very practical hands-on capabilities exiting the FDP, right? So we've got this model, which I acknowledge has issues. And as I said, right now, we're looking to try and see if we can scale this up and explore variants of this model. So I'll just tell you, and I'll close. This is my last slide, I think. So we do try and, the reason we haven't got this sort of set up like a SWAYAM course or something like that is because we feel the technology is changing so fast under our feet that I want to keep the content as fresh as possible, and it's easier for me to do that in this FDP model. So our second batch, for example, is introducing a new type of question. I was just speaking to a colleague before about, what if we want to write, what about a traditional programming questions? Are you saying that students don't write code at all? I mean, are you doing everything by refute? No, we want them to be able to write code. But for example, we've said, here's an interesting, another problem that these generative AI has. We hinted at it in some of the earlier talks. If you give it a problem that is real world in the following sense, every real world problem has a combination of too many details and too few details, right? When you mentioned earlier that you wanted your engineers to ask you questions, you wanted them to clarify the problem specification, I suppose, in some sense, right? I mean, the real world problem is underspecified. It's also got a lot of clutter, and so you have to declutter it, right? So we've been experimenting not with the clutter dimension, but with the other dimension. We give underspecified or low detail problems. And here's what happens. You copy paste that into the generative AI, and guess what it does? It just makes assumptions. Just without even telling you. It just fills in the gaps and produces a solution. But that may not have been what the client wanted. So we've been experimenting with that. So when I meet them at 4 p.m., they're all going to be shouting at me because instead of giving them the traditional fully specified problems, I gave them underspecified problems, but then I gave them a way of clarifying their details. So we'll find out. Okay, we've tried to make the schedule as instructor-friendly as possible. So the way we structured is we have a 10-hour engagement, 5 hours on the first weekend. Then we do some in-week exercises, which are as light as we can possibly make it and still be meaningful. And then we have a 5 hour. So we're on weekend 2 right now. Okay. And as I said, we are acknowledging some problems. So I'm finding it very hard to get faculty engaging with the in-week exercises, which is a shame because that's really where, you know, the value add is. That's where I know something actionable could come out of it, and unfortunately we haven't got that. So I want to suggest that we could look at an in-person weekend one. I feel if we can engage face-to-face with each other, we're much more likely to carry on a meaningful conversation going forward. So I want to share this, as I said, as a contributor to this KIAC Center at IISc. This is in our mandate. If, for example, a state like Kerala would like to take such a model forward, we would be very happy to explore it, right? We are looking for partnerships where we can try and make this. So I wanted to try and end as early as possible so that I have maximum time for questions. So over to you.
So 2 observations, not really questions. For a long time, we've had a rule of thumb that coding is 1/3 analysis, 1/6 coding, 1/2 testing. And it seems in a way what we're doing is letting GAI do the easy 1/6.
Yes.
And what you're doing, I think, is great because it's focusing on the 5/6 that are actually the hard part.
Yes. Yes. Yes.
The other insight I had when you showed the 3 options, in my head I replaced generate artifacts with compiler. And suddenly it made perfect sense, right? Should my students be able to write everything in machine code?
Yeah.
Of course not.
Yeah. Exactly. And I think going back to your fractions, I mean, this is in computer science domain, and everybody else has to sort of translate it equivalently in their domain. So let's say that's the fraction, right? That 1/6 is actually writing the code, and then everything else is all the ancillary stuff around that. The problem is that 1/6 had so many challenges to get students to be able to write it. I mean, computer code, as all of you know, is so finicky. You miss one bracket, it doesn't work. You miss one semicolon, it means something else, right? So it's a very precise language. It's a very unlike a human language, right? So now we're getting them to just focus on being as clear as possible in their language. And here I want to bring back a point that the earlier speaker made about digital poverty, right? So we are in a very linguistically diverse country. And I think the biggest sense in which we face digital poverty is in the fact that very few of our languages have enough of a digital footprint that somebody can actually build large language models over, right? So if there was time, I would show you, but you can also try this yourself, right? You can try and prompt these models in English, they do an okay job. You try and prompt them in another language for which there is a large amount of digital data like Hindi, they do a slightly poorer job, but possibly still okay. I had a student try this in Tamil. It was atrocious, the quality of code that it produced, right? And again, this was 6 months ago. It could have changed, right? But you know, if we're talking about a regional language, which there's no economic incentive for these behemoths to create large language models for, they won't. There are programs by the government of India to try and cater to this community, but I assume that even those programs are biased towards the larger groups, and certainly Malayalam will be one of those larger groups. But you can try it in Malayalam. How does it produce artifacts? I haven't done this. I'm sure some of you would have tried the experiments. But it's definitely, in that sense, we do have this poverty. Because what we really need is people who can articulate as clearly as possible. And the choice of language should not be the barrier in an ideal world. If my student can explain clearly in the language she is most fluent in, that is what I care about. And that is for the artifact, for her ability to produce the artifact. I don't care if she prompted it in English or Hindi or Tulu or any other language, right? Yeah.
Sir,
Yeah.
sir, India has not devised an Indian version of ChatGPT.
Yeah.
Is it because of the rote learning of parrot, or is it because of the lack of algorithmic thinking? What is your take on it?
So, we've missed this boat a long time ago where we failed to adapt our education system to away from rote memorization. Unfortunately, so much of our education system is either memorizations of facts or processes. To the extent that, or some absurd notion of patterns, right? So, for example, if you have to crack JEE, right, you have to do this understanding of patterns which have no bearing for anything else in the real world, right? The ability, what you would go learn at Kota, for example, is learn how to crack patterns and then apply processes and recall facts for problems that have no bearing to the real world. Right?
Sir, in AI terms, pattern matters.
Pattern matters, definitely. They're very good at understanding statistical patterns. And I think we have to be a little bit humble also about what they are much better at than us, in the following sense. So would you say that an AI that has been trained a lot on human-generated data can produce new things? There are many people who say, no, it's just repeating stuff, right? It's a parrot, it's just repeating. It's nothing new. However, if you took standard food items and put them together to make a new dish in a way nobody else had come up with, no one can say you have not created anything new. Someone would be foolish to say, but he's just used tomatoes and onions and this and that. Everybody knew about those. No, but he's mixed them. He's put them together. He's assembled them in a style that nobody else on the planet
Sir, then
thought
what
of
about...
before. Let me just finish the point. Because I think you raised a very important point. So the AI's ability to pull together components from many different domains exceeds us for a very simple reason. Or two simple reasons. One, it's much more broadly read and experienced than any one of us, how much it can read, how much it can ingest. And secondly, its ability to put together combinations of things exceeds our plodding human brain, right? In the sense, it's quite possible that we didn't think of that particular.
Sir, this is the innovative recipe of ChatGPT.
Yeah. Sorry?
This is the innovative recipe of ChatGPT.
This is the underlying technology that tools like ChatGPT can bring to bear that surpass us as humans. We cannot read as much as ChatGPT. We cannot pull together ideas in the same way. It's a different way. I gave you that quote from Noam Chomsky and their colleagues. It's a very different style, right? But I'm telling you those things because I think we should all be aware that even if it is pulling together ideas that were previously known, it can assemble them in new ways. And as humans, we recognize that as novelty. The fact that no one has put this component and this component together, you can get a patent for it. You can get a copyright for it, right? You can't say that this book is the same idea as that story from 200 years ago and this movie from 13 years ago. Well, they have put it together in a clever way which nobody else thought about. So you grant them copyright for example, right?
But we can, in short, we can sum up that it is only stochastic parity.
As I said, I think only is to be treated carefully. we might underplay its power.
Engineering part of the curriculum.
So I actually don't think that is worth doing. I hinted at this earlier. You see, again, if you were running the company that produced these things, why would it be in your interest to have a person come in the middle and say they know how to use your product but nobody else does? It's much more in your interest to design your product in a way that everybody can use it, right? So you should be incentivized, and by the way, I'm putting you in just as a placeholder for someone who is very rich and has a lot of very smart people to work on this problem. I think you would be wise to make it so that the product is usable by everybody, right? So when I get my students to use it, as I said, I allow them to use it. I tell them to apply the same principles of good programming that I would expect students to use anyway. I'll give you one quick example since we have got this. And do I have a minute or? I have 1 minute? Okay. So imagine I want to do the following. I want to write some code that takes two words and compares them to see how many letters are common, okay? If I write code poorly, I'm going to write Python code for those of you who know. If I say I want a function f that takes two words and does something, like compares them, all those words are in my head. If I tell my generative AI to produce the code, look what it says. It says, oh, do you mean x plus y? It has no idea what this function f is. So suppose I apply good principles of programming. You can call this prompt engineering if you wish. I say, well, what I want is I actually want to compare strings, okay? And now it does something different. And I say, no, this is not what I want. I'll give you more context. I actually want you to count how many letters are common in the two strings. I can say that, and now I will get something very different. Using appropriate data structures, like sets, right? So this is the sense in which, if you want to call this prompt engineering, fine, right? But I would say this is the same kind of things that we were teaching students about, and they didn't pay any attention to us. Everybody wrote function with F and I and J and P, and nobody cared about us. And nobody wrote comments unless we forced them. We will grade you unless you cut marks if you don't have comments. Chalo, then we'll write some comments, right? But now, if you want to be lazy, there's a smart way of being lazy, right? Don't write the code, but write all the other good stuff. Write sensible function names, sensible variable names, document your code, and then the AI will understand you and it'll do the right thing. Again, if you want to call this prompt engineering, fine. I think in this sense, yes. But I don't think this becomes a separate discipline. This becomes the same thing, but now there's an incentive for the students to pay attention to it. Okay? Okay, thank you.